Welcome to the lesson on Battery Management System Monitoring Function. In this lesson, we will focus on one of the key functions of the BMS, monitoring. Let us look at our lesson objectives. By the end of this lesson, you will be able to identify the key components monitored by the BMS. Next, you will be able to describe the function of BMS sensors. Then, you will be able to describe the role of microcontrollers in the BMS. Following that, you will be able to identify and explain the use of communication interfaces used by the BMS. Finally, you will be able to describe the overall function of the BMS within the vehicle system. The BMS continuously monitors critical parameters such as voltage, current, temperature, and the state of charge, abbreviated as SOC, of the individual cells and the entire battery. The BMS monitors the battery pack, the voltage sensors, the current sensors, the temperature sensors, the microcontrollers or processors, and the communication interface. As we proceed, we will look at each of these components that the BMS monitors. The voltage sensors measure the voltage of individual cells within the battery pack, allowing the BMS to identify any imbalances or potential issues. The current sensors measure the current flowing in and out of the battery pack, helping the BMS to calculate the battery's charge rate and discharge rate. The temperature sensors monitor the temperature of the battery pack, ensuring it stays within a safe operating range to prevent overheating or undercooling. The battery pack consists of multiple battery cells arranged in series and/or parallel. The BMS receives data from the voltage, current, and temperature sensors to monitor the overall health and status of the battery pack, including its state of charge, SOC, and state of health, abbreviated as SOH. The microcontroller or processors handle the data processing and decision-making functions of the BMS, analyzing data from various sensors and implementing appropriate actions. The BMS communicates with other vehicle systems, such as the motor controller and the driver's display, to provide information and receive commands. By using these interfaces, the BMS can effectively integrate with the vehicle's electrical architecture and exchange information with other systems to ensure optimal battery performance and safety. Interfaces such as Controller Area Network, abbreviated as CAN, bus, Universal Asynchronous Receiver Transmitter, abbreviated as UART, or Serial Peripheral Interface, abbreviated as SPI, are essential for communication between vehicle modules or external systems. These protocols enable the BMS to exchange data and control signals with other components within the vehicle. Let us now look at the lesson summary on the BMS monitoring function. The BMS monitors voltage, current, temperature, and the state of charge to maintain battery performance and safety. Voltage, current, and temperature sensors provide essential data to the BMS for monitoring battery health. Microcontrollers in the BMS process sensor data and make real-time decisions to protect and manage the battery. The BMS uses communication protocols like Controller Area Network, Universal Asynchronous Receiver Transmitter, and Serial Peripheral Interface to share data with other vehicle systems. The BMS integrates into the BEV's electrical system to coordinate battery functions with other critical components. Thank you.